everybody, this is Mrs. Dinkelman, and these are the notes for 4.5. And there's really going to be a couple things we talk about. So one is concavity and points of inflection, and that's going to be based on our second derivative. So really similar to last section where we would find the derivative and set it equal to 0 and analyze on a number line. We're going to do the same thing this time with the second derivative, but that's going to tell us about concavity and points of inflection. And then the second derivative test, this is kind of another option for finding maxes and mins, and it's just an option. So we'll talk about that as well. Really quick, I'm going to go to Desmos just so we can kind of talk about this second derivative, first derivative stuff visually for just a second. And we'll talk about first derivative again, which I know we did last lesson. But if we look at, let's say, a function like, we'll look at a couple different ones. So if we look at x cubed, and then we look at its derivative, we'll be practicing a little bit of this with the graphing next unit as well. So what I want you to notice is, so notice in the blue, that's the derivative. The y-coordinates are always positive, and remember the y-coordinates of the derivative are going to tell us about slope. And notice that the slope of x cubed is always a positive slope, so this thing is always increasing. And we know there's a derivative of 0 here. If we did the number line analysis, we'd get a positive, which means our critical number ends up not being a max or a min. That can happen sometimes. And usually when that happens, it's because of this next thing. So let's compare the original function and its second derivative here. So notice that the second derivative, the green here, does equal 0 at 0, and it does change sign, meaning the y-coordinate is negative here and then positive here. And what I want you to notice is this original, the x cubed, is what we call concave down. It's kind of a frown. Okay, that's concave down. And then it turns to concave up, so like a smile. And so that's what the second derivative is going to tell us about. Again, we can see here, if the second derivative where the y-coordinates are negative, we're going to have a concave down function. Where the second derivative y-coordinates are positive, we're going to have a concave up function. Okay, so there is actually a technical definition for concavity, and this often pops up on the AP exam. So it's definitely worth looking at. And it's this line right here where it says tangent lines lie below. So let me get out my highlighter, and it's this. So if we have something that's concave up, again, think about a smile, which you'll see here is one of the ways Gary talks about concave up. Looks like a smile on the graph. Really, the definition mathematically is that all its tangent lines lie below that curve. And then for concave down, the frown is the opposite. The technical definition is that the tangent lines would always lie above if we were going to try to draw them. Now, I don't tend to memorize that. I tend to just draw a picture of something and say, okay, it's concave up. Let's pick a spot to draw the tangent line. Oh, that looks like it's below. So you don't have to necessarily memorize those because I think the visual makes sense if you just know what concave up and down look like. And then one more bit of vocabulary there, and that is this point of inflection. So basically a point of inflection is where the graph changes concavity. So I'm going to highlight that part. That's kind of the most important part. We also have to make sure that f prime exists, or that the graph has a tangent line. So another way to say number one is that f prime exists. Now I'll be really honest, I tend to forget about that part and just look and see if the second derivative changes sign or that the concavity changes. Okay, and now just to kind of get used to concavity a little bit, on which intervals is the graph concave upward? So concave up are the smile. So it looks like this is probably a little bit of a smile. Smile here, probably, and then a little bit here. Okay, and we can write those intervals down, but let's just, I'm just going to highlight them for now. And then concave downward, where we have some frowning going on. So it looks like those areas look to me like they are concave down. Where is there no concavity? So if something is linear, I don't see anything that's obviously a straight line. It's possible that's a straight line. We have no concavity really at these spots where it changes concavity. Okay, so those are actually the points of inflection. Now I would say this particular point, this is not a point of inflection for a couple reasons. And that's because, well, it's concave up, I think, to concave up. And the other reason is we don't really have a tangent line that we could draw right there. So there's a couple reasons to me that that one is not a point of inflection. Okay, so we are going to analyze concavity here. So we're going to look at the second derivative. And again, there's a little bit in here about how we decide if we're going to include or exclude endpoints. We talked about that last lesson as well. Technically, based on the definition, we should include the endpoints, but the AP exam does not mark you off for having the wrong like brackets versus parentheses there. Okay, so as mentioned before, we're going to find the second derivative, and then we're going to analyze using a number line. So first derivative, 4x cubed plus 3x squared minus 6x, and then second derivative, and remember what we're trying to do is set this equal to 0 or undefined. Luckily on this particular one it's a polynomial, so I don't have to worry about anything undefined here. But I do need to factor so I can figure out where this thing is equal to 0. And let's see here if I can kind of guess and check. I'm going to say it's x plus 1 minus 1. Let's make sure that if I FOIL that makes sense. I believe it does. So we're going to get x equals a half and negative 1. So just like last lesson, like I said, we're going to analyze. Again, let's make sure that we label this, especially now that we know we're going to analyze in different ways. We need to let the grader know what we're analyzing. And it's also helpful for us to know what we're analyzing. Okay, so remember we pick something in each interval. So let's say like negative 2. So that's going to be a negative times a negative, which would be a positive. Let's pick 0. Negative times a positive, which would be a negative. And then let's pick like 3, so that'd be positive, positive. Okay, so there's a couple things we can answer here. Let's answer concavity, so concave up. That's where we have positive second derivative. So negative infinity to negative 1. Again, technically a bracket, but if you put a parenthesis, that's actually what makes sense to my brain at least a little better. Okay, and then concave down. And so that's from negative 1 to 1/2. Again, I like parentheses there, but you decide. And then points of inflection. So I'm going to call those POI, where the derivative or where the second derivative changes sign. Those are the x coordinates for the points of inflection. So we have negative 1 comma something and 1/2 comma something. And we would technically want to go back and make sure that the first derivative also exists, but luckily our first derivative is a polynomial, and we know that that's going to work out for us. So let's see, I have my calculator out here, and we'll just try to figure out what the y coordinate is for the points of inflection. Luckily negative 1's not too bad. So if I plug in a negative 1 here, I'm going to get 1 minus 1 minus 3 plus 1. So negative 2, I believe. You guys check me on that. And then when I try to plug a 1/2 in here, I'm just going to do it on the calculator I have in front of me here. So 1/2 to the 4th plus 1/2 cubed minus 3 times 1/2 squared plus 1. 7/16 it looks like, but definitely check me on that. Okay, I think that's probably enough to talk about. I know there are other examples here, but what I would recommend is that you go ahead and pause and work on the problems in your textbook that have to do with that. Let me find that real quick. Sorry, I don't have that ready already. I probably wrote it down. So like 1 through 8 are asking you to do those where you do the number line analysis and determine concavity and points of inflection. So try 1 through 8 and then come back, or maybe it's 1 through 9. Try 1 through 9 and then come back, and we'll talk about the second derivative test for maxes and mins. Okay, so for the second derivative test, what this can do is actually help us find maxes and mins also. It's really like a second option for finding whether something is a max or min, and it's usually totally optional. I've seen a couple of problems here and there where they force you to use the second derivative test, but many times you can use the procedure from the lesson that we just did before. So just picture-wise, let me kind of tell you what's happening. Remember what we're doing is identifying where the derivative is 0 to determine whether something is a max or a min. But what I want you to notice here is if we have a minimum, that we have something that's concave up. So we could technically use that 0 from the derivative and check to see whether we have something that's concave up, which would indicate a minimum, or something that's concave down, which would indicate a maximum. So we're going to go ahead and find the critical numbers from the first derivative. So take the derivative there, and then let's see, I'm going to factor out a negative 12x. So it looks like our critical numbers from the first derivative are 0 and then positive or negative 1. Technically, make sure you write equals 0 there so that the grader knows how you got that. But technically, we should also look for where it's undefined, but it's a polynomial. Okay, so in this one, again, one option is, what it just did to me. One option is to do this number line analysis like we did last lesson. Okay, that's one option. This is really the second option, and I will tell you as a student, I just didn't really love this option. So I'm going to take the second derivative, negative 36x squared plus 12. Now what I'm going to do is take these critical numbers and plug them into each of those and kind of see what's happening. So I'm going to get the second derivative at 0 and at 1 and at negative 1. Okay, so for 0 I get 12, and honestly I don't really need to know the number here, I just need to know whether it's a positive or negative. So that's a 12, and then let's see, that's going to be negative 24 if I plug in a negative 1, and then same for, or positive 1, same for negative 1. So remember, if the second derivative is positive, what I'm telling you is that we have something that's concave up. If it's negative, it's concave down, concave down. And remember, if it's a critical number, that the derivative is also 0. So we're talking about kind of those locations right there. So now what we know is that there's a minimum at x equals 0, and there's local maxima at x equals positive and negative 1. We could go back and find the points by plugging those into the original, but that's how we're going to use that second derivative test. Okay, so let's just look quick at 8, and then you can go along to the assignment. So we have some information here. So the things of interest to me are these ones where the first derivative is 0. Okay, I'm not going to look at that row because the derivative is not 0, so I know it's not a candidate for a max or a min. And then let's look at the second derivative. So again, where the second derivative is positive, we know what we have is something that's concave up. And again, the first derivative is 0, so those must be minimums. And then let's see, where the second derivative is negative, we know what we have is something that's concave down, so that must be a max. And then where both of them are 0, we don't really know what's happening there. We'd have to analyze further, but it's neither a max nor a min because both the first derivative and the second derivative are 0. Okay, so go ahead and get started on the assignment.